Welcome to video lesson 8.2, and today we're going to look at dividing monomials. Go ahead and put today's date in the top right hand corner and write down our I can statement. Today's target is that I can divide monomials, raise monomials to the zero power, and manipulate negative powers to become positive powers. Now, the first thing we'll look at is our rules for multiplying monomials. And basically, they're the reversal of our multiplying. So where we multiply our coefficients, for dividing monomials, we're going to divide or reduce all coefficients and constants. And remember, that word reduce there means we want it in simplest form. So if you have a fraction like 2 over 4, reduce it to 1/2. And then we're going to subtract our exponents of like bases. Now, two quick rules to write down next are that all bases raised to the zero power simplify to 1. So that means anything and everything raised to the zero power will simplify to 1. And lastly, no negative exponents allowed. We know that from our examples of monomials. But if we do get negative powers, to make them positive, we change the location of its individual base. So it's just that one variable or just that one base number in a fraction. So change the location of its base in a fraction. And these last two about the zero power and the negative powers, we'll come back to those here in a moment. But first, let's look at dividing monomials. So our first example has a to the 5th, b to the 8th, all over a, b to the 3rd. So we first look, that fraction bar tells us we're dividing, so we first want to divide our coefficients. But we don't have any coefficients to divide, so we skip on to our variables and their exponents. Have an a to the 5th on top. And technically down here, if I have a 1a, that means I have a to the first power, just that one's hidden. And we subtract our exponents. So we do 5 minus 1 gives us a to the 4th. And we drop down our b. Then 8 minus 3 is b to the 5th. There we go, and that's our dividing monomial. So let's look at one more. So example 2. We have 2p squared all over 3 to the 4th power. So this one has multiple steps in that we need to worry about our exponent and our division. So this is where the order of operations kicks in. We have to use our exponent before we can divide. So we're going to distribute it to everything. So it's going to be 2 to the 4th power. And then we multiply our variable p's exponent of 2 to the 4. So p is going to be 2 to the 4. And then my 3 also gets distributed, so 3 to the 4th power. Now we're just going to reduce. So 2 to the 4th power gives us 16. We drop down our p. And 2 times 4 is 8. All over 3 to the 4th power is 81. So then we look and we want to always check this last step to see if 16 over 81 can simplify. It can't. So that's our answer. That's as far as we can go. And one more for division. So our next example is 9b to the 4th, c to the 5th, all over 36b c squared. So for dividing, our first step we want to look at is divide our coefficients. And 9 over 36 won't reduce evenly because 36 can't go into 9. But it is a fraction that can reduce. And we say 9 can go into 9 one time. and 9 can go into 36 4 times. Now if you look at this step down here, I made a long fraction bar. And that's because whenever we're dividing, we always want to put our variables on the top part of the bar. So if we get the fraction 1/4, we make a long bar and we're going to put our variables on top. So I'm going to drop down my b. And once again, that's b on the bottom here is b to the first because it's 1 there. So we're dividing, so we subtract our exponents. So 4 minus 1 is 3. I drop down my c and do 5 minus 2 is 3. And that's as far as we can go, and that's our answer. Now this will help us later on to go ahead and start writing it this way. However, if you're on a multiple choice test, sometimes you'll see it written 1/4, b to the third, c to the third. Both answers are correct. It's just the way in red will help us out when we get into our next sections. Alright, and you don't have to rewrite this rule. You already have it. It says all bases raised to the 0 power simplify to 1. This just kind of proves why it does. Okay, so if you have, look over here at the right side with me. If you have 2 to the 4th power over 2 to the 4th power, you have 4 2's on top, 4 2's on the bottom, and they all cancel each other out. And 2 divided by 2 gives you 1. So over here, if you do 4 minus 4 gives you 2 to the 0 power, that would simplify down to just 1. So here's an example of our 0 power. So if I have negative 3x to the 5th y over 8xy to the 7th to the 0 power. If you remember, whenever we have our power on the outside, when we have a monomial being raised to a power, it gets distributed. So everything in here gets to go to the 0 power. And because everything inside this parenthesis goes to 0 power, everything in the whole parentheses reduces down to just 1. Because the whole parentheses raised to the 0 power. So those are some of my favorite problems, because if you see a big parenthesis and it's all raised to the 0 power, you know it's automatically just going to be 1. So here's another example for our 0 power. So we have t to the 3rd, s to the 0 over t. So let's see what we know. We know that s to the 0 power is going to give us 1. And we know if they're side by side, that means they're being timed. So that's t to the 3rd times 1 over t. Now t to the 3rd times 1 just makes 1 t to the 3rd, so we don't have to show that 1 anymore. So we just write t to the 3rd over t. And now that fraction bar means we're being divided, so we need to subtract our exponents. So 3 minus, there's 1 down here, so 3 minus 1 is t squared. Another way to do this problem is just go ahead and say s to 0 power cancels out, and so you're left with t to the 3rd over t, and you end up with the same answer. Alright, our next one is no negative exponents allowed. And once again, if you look right here, it shows 2 minus 5. Ooh, grab the white out instead of the highlighter. 2 minus 5 gives us a negative 3. What that means is I have 3/8 left on the bottom, and the top simplifies to 1. So if I have 8 to the negative 3rd power, and I put it over 1, we say he doesn't want to be on the top. He wants to be on the bottom. So let's see an example of this. So example, don't remember what number we're on, so this will be example 6. We have b to the negative 3rd, c squared, over d to the negative 5th. So that fraction bar tells us we're dividing, but we look, I have b to the negative 3rd. Do I have any other b's? Nope, so he's just by himself. So now we're going to simplify and say b to the negative 3rd. We can't have a negative exponent. So if he's on the top part of the fraction, he doesn't want to be on the top. He wants to be on the bottom. So what I like to do is I like to go ahead and make my fraction bar and show them as I move it. So b to the negative third doesn't want to be on top. He wants to be on the bottom, so it becomes b to the positive third. Then we look at our c squared. His power is positive, so he wants to stay on the top. He wants to stay where he is. Then our last variable to look at is d. So I have d to the negative fifth. His power is negative. So he doesn't want to be on the bottom part of the fraction. He wants to change his location and go to the top. So d, and because he went to the top, is now to the positive fifth power. And that's our answer. We can't go any farther because they're all different variables. And remember, whenever you write out your variables, you always want them in alphabetical order. So it's c squared d to the fifth while you're changing their location. Alright, and this is example 7. We have negative 3 a to the negative fourth, b to the seventh, over 21 a squared, b to the seventh, c to the negative fifth. Okay, so that fraction bar tells us we're dividing. So the first thing we want to do is see if we can divide or reduce our coefficients. So negative 3 divided by 21. 21 is on the bottom, so that means we're going to end up with a fraction. So negative 3 can go into, 3 can go into negative 3, negative 1 times. 3 can go into 21, 7 times. Then we look at our variables. So I have an a to the negative fourth and a squared. So when we're dividing, we subtract our variables exponent. So negative 4 minus 2 gives us a to the negative sixth. And then b to the seventh divided by b to the seventh. So we know that 7 minus 7 is going to be 0, and 0 power means 1. And rather than writing that out, we can just say the b's cancel. If we have b to the 7th divided b to the 7th, they just cancel out. And I'm left with c to the negative fifth. He has nobody on top to go with, so we can just drop him down if he's right where he is. Alright, now we get to this last step and we say, is that answer good enough? Is it correct? And we see our negative power, so we know, no, it's not. So I'm just going to bring across my fraction bar. And my negative 1 over 7, I can't reduce that anymore. So my coefficients don't have anywhere to reduce because they don't have any powers. Now look at my first one. I have a to the negative 6 power. He doesn't want to be on the top. He wants to go to the bottom. So over here I'm going to write a to the positive 6th on the bottom of the fraction. Same way, my c to the negative fifth didn't want to be on the bottom anymore because he has a negative power. He wants to go to the top. So it's now c to the positive fifth. And that's our final answer. And this concludes us for our 8.2 video. Hopefully you've reached your targets, and thank you very much.